We present Solid Sketch, a 3D parametric modeling system employing naturalistic sketch and multi-touch interactions while still providing the computational power of 3D modeling programs such as CAD tools.
At the beginning of the design process, the user employs Solid Sketch to draw freehand sketches in 3D to explore their designs, including the layout of the floor plan and the form of the building.
While interacting with the 3D canvas, the user can build simple templates that consist of rules recorded through interactions after hitting the plus button on the left panel. After hitting the button, the system will show an orange line to signify the starting location for the new template. The user can then build the template around the original line by defining a geometric rule. For example, we first draw a short line segment to represent the width. When the Extend Dimension button is selected as shown in the upper left corner of the UI, the user can extend the selected line segment and trace the template line to generate a 2D offset surface, which becomes the profile shape of the wall. The same Extend Dimension rule will extrude the 2D surface to 3D geometry. After hitting the plus button again, the user can draw an icon for the newly created template. A template consists of relationships between the newly created geometries recorded during interactions in template building mode. When using the template, the orange template line will be replaced by the sketching line, which generates the geometries based on the rules captured during the template generation procedure.
Using similar methods, the user can also build complicated templates. When users choose this template to draw geometries in real time, the system intelligently selects important geometries to render first. Please refer to the paper for more details. With these two templates, the users can quickly create a building with columns, walls, slabs, and openings. Once a user has the rough sketch of the building, she can also export it as an IFC model that describes not only geometries, but also the basic semantics of the building. She can then import the model into Revit to add more precise details. Since the exported model describes the relationships between geometries, when the user modifies one of the objects in the array, Revit knows how to update all the elements in the array. Here, we describe the interaction designs of Solid Sketch that enable an architect to explore their ideas in the early stages of design.
The user can create an accurate rectangle by performing right-angle gestures at the corner of the shape. The user can also oversketch on the selected polygon to modify the shape. In this case, we're trying to create a staircase,
and use the Array tool to create the entire shape.
To create a staircase, the user can perform a small lasso gesture to activate the Access widget, then tap the desired surface. Next, the user sketches a path while the Array template mode is selected. The system will generate a series of shapes along the path. To adjust the number of shapes in an array, the user can hold the first shape with one finger and move another finger with the other closer to the first shape. The system will then add new shapes when there is enough room at the end of the path. Similarly, after the user moves the grid plane on top of the wall, the user can draw and modify the slab of the second floor. Creating a skylight in the house is simple. Drawing directly inside an existing polygon will create a hole in that polygon. After the slab is finished, we can draw a wall right on the slab using the same template we made earlier. Here, we're designing the plans of the second floor. With the Array template, we can create columns and windows that show more details of the building. If the user wants to create a window, she can dig a hole directly on the surface she wants the window to appear. She can select a base shape and perform a scratch gesture to accomplish the goal. Since this is a parametric model, the system is capable of exporting XML files that describe not only the geometrical information, but also the relationships between the geometries, which can be utilized in later stages of the design process.